Right. So maybe to explain a bit the backgrounds why this is really important subject, we need to take a look on the energy consumption forecast for data centers, and we can see that it will be rapidly growing in the future. What makes it very interesting is that most of it is generated by renewable power, which is of course a good thing. But then having lots of renewable production, that means for the power grid actually that there will be more and more volatility. We don't know how much we will have production in the system, so there is more inaccuracy on that one. On top of that, when we replace big rotating masses in the power grids, we are losing some inertia, which is then resisting the change of frequency if there is imbalance. So actually this is making the power grids a little bit less stable if we don't do anything for that. Simply if you look on the demand and supply, in the power grids we target to have both equal, then we get the perfect 50 Hz frequency to the grid. If there is deviation between the consumption and production, the frequency starts going below or above 50 Hz, which is not desired. And for that, we really need to have reserves that help us to keep this balance no matter what is the deviation on the production side or the consumption side, to balance that thing. UPSs are a great asset for that because they always have some stored energy connected, which is there waiting for bad day to happen and back up the critical loads in the data center. And that has been the only purpose of a UPS so far. But now actually with the latest developments, we have, I would say, revolution in the UPS design. So the UPSs today, they focus on keeping the high availability and doing the main purpose of the UPS, which is the load protection. We try to do it as efficiently as possible to make as low total cost of ownership as possible. And those kind of features have been there in the UPSs for many years already. But now actually the next step is that we will have this kind of a smart energy features in the UPS that will help us to utilize better the stored energy that is connected to UPSs. That can deliver some additional revenue for the data centers, and also it will allow the data centers to be also more sustainable, contribute for the green energy, let the grids to adapt more renewable power, because the data centers have the assets that can really compensate the impact of the high renewable usage. Another alternative to balance the grids is building battery storage. And for that actually you need lots of power and electricity infra. You need to have transformer, you need to have the switchgear, then some power electronics to connect the batteries, and then of course suitable batteries for that purpose. And about 50% of the battery energy storage costs comes from this power infra that is lying upstream to power electronics, transformer, switchgear, the building itself, the land, and so on. And now if you look what you really need in the data centers to protect your critical loads, you can see lots of similar equipment. You have the grid connection, you have the transformer, switchgear, power electronics, you have batteries. So everything that you actually utilize while having a battery storage dedicated installed somewhere in the power grid. This naturally means that it is very cost effective to use data center infra that is already built for another purpose, but it could be utilized for this kind of secondary applications as well. And looking on the opportunity, only Eaton in Europe has 1,200 megawatts of installed base that could be put for this kind of usage by firmware upgrade. If we count on average 10-minute battery, like we have in the normal UPS application, that would then mean 200 megawatt hours of stored energy lying on the grids waiting for the bad day to happen. So we can be more clever, utilize it better way, and get some additional value from the necessary investment. Taking the existing UPSs in use is something that is really now happening. And Mikael here is to tell about the Sweden first energy-aware UPS. That's a UPS that was upgraded for this functionality and is soon participating in the Swedish market.
Yes, we are at Bahnhof, and for you who don't know who we are a cloud service provider, co-location provider, and internet service provider since '94. And we have 4 data centers here in Stockholm. And we like to lead by being the first adapter in many technologies, as in 10 gigabits of internet to private customers in Sweden. We were the first to utilize data center waste heat in district heating here in Sweden, Stockholm. And now we, with the help of Eaton and Jussi, the first to offer stored energy in batteries to support the Swedish grid. We also like to show off with being efficient by design, and UPSs go in constant energy savings mode, and we design our own cooling system for being as energy efficient as possible. Our waste heat utilization is about 2 megawatts of heat that we provide the district heating systems here in Stockholm from 3 data centers. And we also designed this in our future constructions design. So we think that in environmental reasons, and of course not showing red numbers in the end of the year, getting some revenue for it is also a good reason to do it, of course. So taking the first UPS to the Swedish grid once the market opens, we saw as a good opportunity to show that we like to lead with being the early adapters in new technologies. And while we could do it with minimal costs, since we already had the UPS for it, so all it required was a firmware upgrade. Of course, we were worried about what about the critical load? How can we protect that? As a data center manager, you're always worried about the critical load. And considering our redundant two-end design and a very reassuring presentation and showing how the technology works from Eaton, we felt safe to go forward with this project. When we first found out about this project, about this technology, we looked forward in why and how it can be enabled, and we contacted our supplier of UPSs, Eaton, and it turned out that they were having a pilot together with Fortum here in Stockholm, and we told that we really want to see the results of this pilot, and it showed very promising results, and we got the word that Svenska Kraftnät will go forward with this. So we started a discussion with Eaton on how we can go forward with this. And as I mentioned, our concerns were eased by Eaton together with our own design. The most aware data centers are using green energy and renewable energy. Data centers are being a part of the problem. We also like to be a part of the solution with supporting the grid in these UPS installations.
Yeah, and the next 2 points really are linking back to the first slide. So the stored energy that is really required to be able to deliver the required amount of power every time required for the consumers, because there is more volatility and we need to have flexible reserves to resolve the issue. And the other point really is that we actually can have positive impact on the grid reliability also by offering this kind of flexible reserves, because they act so fast that they can replace part of this lacking inertia that is a consequence of adapting more renewables.
Exactly. And as data centers, we are the fastest growing energy consuming market in the world. So we feel that it's important to take responsibility and make the best of it.
Mikael was referring on the pilots, and then I was also promising that this is something that anybody can do if they are having their operations in such kind of market that allows offering battery stored energy for grid support purposes. So over there you see actually a map on the markets that are currently active. You might find markets from Finland, France, Belgium, UK, Ireland, and now actually Sweden will be dark blue next month, so Swedish market is opening as well. And then we have some other interesting news on the pipeline as well for the next year, that there will be probably even more opportunities for this kind of application. And really to validate the concept, validate the technology, and also to meet the expectations of the grid companies. So we have done piloting, of course, with those grid companies to show them that this is something that they really can leverage. We have done the pilot in Sweden about a year back with Svenska Kraftnät, which is the Swedish transmission system operator. That pilot was followed by a pilot in Norway with Statnett, that is the Norwegian the transmission system operator, and then also we have done some piloting in UK with one large co-location data center. The pilot in Norway was really interesting because that was done with a live data center having 1.4 megawatts of UPS power in 2 different data centers. And by a coincidence, while we did the pilot, actually a nuclear unit in Finland was dropped off from the grid, which caused the frequency to go down to the 49.6 hertz. And that actually activated the UPSs in Norway to support the Scandinavian power grid. And the nice thing in the pilot was that the customer really didn't see anything. So the UPSs continued to protect the load while they also helped the grid. So this is really nice case actually to show that this really works. It's not only concept, but this is something that really can be utilized and also in safe manner. There is opportunities. We have different kind of markets, different kind of applications, and you might find this kind of up and down markets where you can do up and down regulation for the grid. So meaning charging and discharging the batteries based on if you are above or below 50 hertz. Typically that is the best compensated market, so you can earn over 100,000 euros per megawatt per year by participating for that market. But that market actually requires a bit investment on the batteries, so it will be very cyclic usage, so you would need to have correct type of lithium-ion batteries for that application. Then we have this kind of dynamic containment where we do up-regulation only. So based on how much we deviate from 50 hertz, we will give certain power response, meaning that the UPS is not consuming from the grid, or it might be feeding power to the grid. And the compensation is around 30 to 70k euros per megawatt per year, depending on the year, depending on the market where you attend. Then in Ireland, there is this kind of a static containment market where you basically do up-regulation as well, like in this FCRD case, and that market is also paid quite well, so you can expect to earn something between 50 to 70k per megawatt per year. And those examples on the right side, actually, those you can address with lead-acid batteries also, so that becomes very interesting thinking of the existing installations. There will be also good opportunities on the future. So Statnett from Norway just told that there will be a new fast frequency reserve market for Nordics, very similar to what we piloted in Norway. And that's perfect for lead-acid batteries because the frequency limit is so low that we expect very few activations. So that's something that you could consider attending with lead-acid batteries. And then, of course, UK, it's a big market, having lots of data centers, lots of stored energy. So they are also planning some new frequency response services for UK that are more closer to opportunities in Scandinavia and in Ireland. The schedule is still a bit open, but that's the kind of a first information we got from National Grid in UK. And this is really developing continuously when the grid companies recognize the opportunity and establish the markets. I told that we are also doing it. We are not only saying that it's possible. So we have already some commercial applications starting up soon. Eaton trusts its own technology. Therefore, we put actually the UPS is protecting our company headquarters servers to support the Irish grid. That is being commissioned this month, and straight after that it will be supporting Irish grid. It will participate to this DS3 market, and we expect to earn about, let's say, 7,000 euro with that UPS. It's small UPS only, not megawatt size UPS. In Sweden, we have, like mentioned, Bahnhof is really the first one to go to the market, but then there is another one also, 1.2 megawatts with lithium-ion batteries, and both are addressing this FCRD market where we control the frequency up when required. Then in Finland, we have one case also, one customer in city of Oulu, who is participating for FCRN market, which is then controlling frequency up and down based on the if we are above or below 50 hertz. And that is done with certain kind of lithium-ion batteries that supports this kind of cyclic usage. Why data centers then should do it? So of course, first of all, this is really a green contribution for the grid. You can help the grids to adapt more renewable power by providing flexible reserves to compensate the issues they generate for grid. Of course, money is always also a good motivator, so the grid companies are paying compensation for this kind of usage of batteries. That's then allowing them not to build that much backup power plants, so they win in this kind of case as well. And for the data center especially, if the infrastructure can generate money, that might allow the data centers to build their infrastructure already upfront and generate some money from the market. And while you have the infra built, you can take quicker in a new customer, which of course provides some competitiveness in the data center market. Speed is competitiveness. How then data center can be more energy aware and address these markets? So first of all, of course, you need to have the right UPS technology. First of all, for that reason, because you probably want to make it safe. Load protection is always the priority number one, and that should be taken into consideration when you do this kind of applications. You should not sacrifice the critical loads. If you have versatile design for the UPS, that can be flexible. You can address more opportunities because different markets, different applications requires different kind of response from UPS. If you have versatile enough UPS design, you can address more markets and maximize your earnings with the asset. And then, of course, if you have the right UPS, you can even use the ones you have on site already by firmware upgrade. Then, depending on what kind of usage you are looking at, what kind of markets you want to address, so then you really need to pay attention also on the battery selection. There are some opportunities that you can address with lead-acid batteries, but as we know, they do not tolerate too much this kind of cyclic usage. So you really need to look on the statistics of the grid, that what's doable and what's not with the lead-acid battery. There are opportunities, but they are more limited than with lithium-ion technology. And then also, if you need to have lithium-ion technology, you need to be careful what kind of lithium ions you are purchasing. Not all lithium ions tolerate cyclic usage. So depending again on the application, you need to select also right kind of lithium-ion batteries for your case. Then of course, to make it happen, to get to address the markets, you need to have somebody between your asset and the grid. You probably want to have some expert who is then giving guidance on for what price to trade, how to maximize the revenue from the market. And for that reason, actually, we like to work with energy companies or aggregators who are professionals on that field. So they know for what price to bid, what's the best use of assets in the market, and then they also have all the required interaction towards the transmission system operators, and they do all the required reporting. One interesting point is if we refer back to the slide showing why this makes sense and how this compares to building battery storage to the grids. So energy companies have motivation to fund this kind of application. So you might find a partner actually to fund part of your power infra, because it makes sense to make the same application inside the data center rather than building it separately to power grid. So as a conclusion, the future power grids, they really need fast, flexible and cost-efficient reserves, and data centers will touch all those points. Maintaining the low energy price and the reliable grid, they really require common effort. So the ones who are consuming renewable power should also help fixing the issue. When we think about the grid-responsive buildings, to which I would include the data center, so they can also, by doing right things, they can reduce CO2 emissions, because batteries can replace this kind of reserves that are based on the fossil fuels. And also, while we provide flexible reserve, the grid can adapt more renewable power, which is of course a good thing. It's naturally much better use of assets than it was with the conventional UPS design, so you can take the best out of the necessary investment. And with right technology, this can be flexible, it can be secure. It's the details in the design of the product that really matter and make it possible and make it reliable.
Does it imply that you have overcapacity in relation to your customer load when you expose these services to the grid? Or how do you think about the dimensioning of how much you could offer the grid in relation to your core business?
In short, you can say that the aggregator or Svenska kraftnät, they never send demands, they send requests, and the UPS takes the decision if it has anything to offer or not. So the critical load is never in any danger in that aspect.
Thank you for the question.
Thank you.
Thank you.
Once again, thank you very much for your presentation. A good round off to the morning sessions.